Well, we're going to finish up the last two problems of Unit 2C. And for question 8, we have two cyclists, 42 miles apart, begin riding towards each other on a long straight avenue. One cyclist travels 15 miles per hour, the other one 20 miles per hour. Will you agree then we can combine their rates of speed, and 15 plus 20 is 35, so they're eating up this 42 miles at a rate of 35 miles per hour. At the same time, Spot, a greyhound, starting at one cyclist, runs back and forth between the two cyclists as they approach each other. As Spot runs 38 miles per hour and turns around instantly at each cyclist, how far has he run when the cyclists meet? Well, let's make a chart, and we know that rate times time equals distance. And we've got the bicyclist, and their combined rate is 35 miles an hour, and their distance is 42 miles, and we know this, that time equals distance divided by rate. So their time is going to be 42 divided by 35, and since 7 is a factor of each, that will reduce to 6 over 5. So their time is 6/5 hours. Now Spot is traveling at 38 miles an hour. He's going to travel for 6/5 hours, and so his distance will be 38 times 6 over 5. And the product of those two using a calculator is 45.6 miles. So Spot will travel 45.6 miles, while the combined distance for the gentleman is 42 miles. Now for the last problem, 9. Suppose that 8 turns of a wire are wrapped around a pipe with a length of 60 inches and a circumference of 4 inches. What is the length of the wire? Let me clue you in. This is typically a test question. The numbers won't be the same, but the question, the verbiage will. So please make sure you know how to do this. So we've got some pipe, and will you agree if we take this piece of pipe, cut it down the middle, spread it apart, what we're going to have is a rectangle. And that rectangle is going to have a width of 4 inches. And it's going to have a length of 60 inches. Yeah, so this distance here is 60 inches. And let's see, I would say this looks like about halfway between, and this would be about, there's 8 turns of the wire, so we need 8 wraps, and half, so I'm just going to approximate half, and then the halfway marks, and so half of this distance is about there, this half, and this half, and this half. Now we're going to draw a line across at each halfway mark. And we'll also draw a diagonal, and this represents the wire. Now if we were to fold this, reshape this in pipe form, this wire would again start here and go to there, and so on, if we were to reform that rectangle into the shape of a pipe. These 2 points would be connected. So what we have in each case is a right triangle, and the width of the right triangle is 4 inches, and the height of the right triangle is going to be 60 divided by 8 inches, which equals 7.5 inches. So this is 7.5 inches. Now, the length of each one of these diagonals, I'll call it the hypotenuse, and so h equals the square root of 4 squared plus 7.5 squared by the Pythagorean theorem. And now the length, the entire length of the wire is going to be, in fact, let's compute this right now. And so we've got the square root, square root of 16, which is 4 squared, plus 7.5 squared, close the parentheses, and we get 8.5. So the length of the hypotenuse is 8.5, and so the length of the entire wire is going to be 8 times 8.5, because we have 8 wraps. 8 times 8.5, and 8 times 8 is 64, and 8 times 5 is 0.5 is 4, and 4 and 64 is 68, so that's going to be 68 inches. And we're done.